In this video, I want to talk to you about VSEPR theory and wedge dash line notation. So let's just jump right in. We're going to get it going right now. So what I really want to focus on for this video is showing you exactly how to read a VSEPR theory chart. Now you have several charts available to you. You can go online, you can find one you like, but this is the one that I make available in the classroom. It is in the supplement section. You can find it fairly easily. If you don't see it in your class, in your supplement section, ask your instructor and your instructor can make it available to you. Okay, so it is actually 2 pages. Could not fit both pages where you could see each one of them on the slide. So I just wanted to show you that it's actually 2 pages, but we do have some rules to follow. And you guys are probably tired of hearing me say that because we have lots of rules in chemistry, but here we go. So the first rule is there is no such thing as a stable AXE4, AXE3E3, AX2E4, or AXE5 molecules. Now, this might confuse you before we get into it and I teach you how to read this chart, but you can always go back and reference this particular rule and see what I'm talking about. Okay, so second rule, all bonds are represented in these tables, this table, and probably almost any other VSEPR theory table you're going to find, as a single line. It doesn't matter if it's a double or a triple bond, we have a single line, and regardless of what we're actually, what the bond is, it's represented as one single line, and you're going to need to draw them that way. And it's going to get, it's really easy. I'm going to show you how to do it, okay? So the third rule of thumb is you're going to count your atoms and your lone pairs in order to determine your domains. You are not counting bonds, only your atoms and your lone pair. All right, last one. The number of bonded atoms plus the lone pair always add up to the number of domains. Say it one more time. The number of bonded atoms plus the lone pairs always add up to the number of domains. So let's just show you the chart, because the chart has all the answers. It shows you how to draw all your 3D structures, has all the answers. So let's pull this little chart. I made it a little bit smaller, I know, but we're going to look at the chart. Now, what I want you to know is that we're looking at generic formula. Our generic formula is right here, okay? When we're looking at our generic formula, your A represents your central atom. Your X represents all of the outer atoms. And then your E is your lone pairs of electrons on the central atom only. The only thing you're looking for are lone pairs of electrons on the central atom. Okay, that gives you a little bit of a heads up. So we're looking at the generic formula, and that formula shows you the picture. It shows you exactly how to draw it, like exactly the shape, everything. Okay, dashed, wedged, whatever the case may be. It shows you how many bonded atoms you have, how many lone pairs you should have on that central atom. It gives you your molecular shape and your electron geometry. And while we're not getting so much into that right now, you will, at least you'll know on the chart how to use it as a guide to answer all the questions that are asking about molecular shapes or electron geometries and all the things in your molecular modeling lab. All right, so first example, we have PCl5. I went ahead and drew this Lewis structure mainly because this video is not about Lewis structures, right? So if you're struggling with Lewis structures, go into the video library, find your Lewis structure video, and that should give you a little help. You can always ask your instructor also. So I just want to show you guys, right? Our A is going to be our phosphorus. Our X is going to be all the chlorines that we have, right? And then our E are our lone pair of electrons. And how many do we have in our central atom? None of them at all. So we're not worried about E. So if we write out our formula, our what we're calling AXE notation, what we're looking at is we're looking at an AX5. There's no E. So AX5 is what we're looking for. If we have AX5, we're going to go to our generic formula column and we're going to look for AX5, and there it is. So we have all the answers going across to the right. We have the picture, we have the bonded atoms, we have the lone pair, we have the molecular shape, electron geometry, all the things we want to know, hybridization, bond angles. You're going to need all that stuff when you're working in your molecular modeling lab. But for all practical purposes, let's show you some things. This picture right here is exactly how you're going to draw this particular compound, okay? We know we have 5 bonded atoms because we have 5 chlorines, right? And we know that there are no lone pair. There was none actually put on there. And like I said, your molecular shape, your electron geometry, all that's going to be necessary when you are working on your molecular modeling lab. So if I'm going to draw with my wedges and my dashes, I'm literally looking at the picture, this picture right here, and it tells me exactly how to draw it. Also, I want to reiterate that your wedge and your dashes, they don't really matter if they go at the top or the bottom of these 2 particular chlorines, as long as they're both there. But I literally am following that picture, so I know that mine is going to be right. So for another example, I wanted to do a BRF3. And again, I went ahead and drew that Lewis structure for us. And what we're looking for is we have an A, and that's going to be our BR. And then we have our X, and our X is actually going to be our fluorines this time, right? And then E. Our E are lone pairs of electrons that are actually on our central atom, and there are 2 of them. We have one here, one set here, and one set. We are not counting dots, but we are counting groups of dots. So how many of a lone pair? Lone pair is 2, okay? Just to reiterate. So what are we looking for? We're looking for AX3, E2. And I go and I find my AX3, E2 on my generic formula on my VSEPR chart. And then I know that I'm going to be drawing my structure like an AX3, E2 picture on the chart. I know that my structure is going to be correct because I'm literally following the picture right there. I've got 3 in the plane. Those are my fluorines. Remember, X is a fluorine in this problem. A is a BR, and then we have 2 lone pair of electrons attached to our central atom. So if you have any questions, you should direct those to your instructor. Go into the video library, see if there's other videos that kind of compensate this particular one if you're struggling in a particular area. I hope this video has helped you out.